After we discuss about the list implementation, we want to see some special case, which will lead us to two special scenarios of the list. They are stack and queues. In this chapter, we want to take a look at the stack. So what is a stack? In order to let you guys understand, let's take a look of three interesting examples. Consider you are writing a program for playing cards. So for a poker game, this structure needs to do the following things. On any turn, a player can discard a single card from their hand to the top of the pile. So that's one choice of the operation. Or instead of discard the card, they can retrieve the top card from the pile. So this is the kind of scenarios that we are facing in the stack situation. Next one is an interesting parking lot. So in this parking lot is a very small and narrow parking space which can hold probably at most 6-7 cars. So think about this. If there are some cars are waiting over there and try to go into the parking lot, saying that this is the car that comes in, if we want to remove a car, that would be the same car that has to move out first. This kind of situation is not a story. There's experiences that I had is that one of my cousins find a very cheap hotel in New York, which cost him only $40 a night. The only thing that he made a mistake is that he drove his car from Atlanta to New York. Once he arrived at that very late night, they charged him $40 for his stay. However, the parking cost for overnight in New York is $60. So he actually ended up with paying more than himself for his car. So look at this kind of things. It's also showing similar things that we have in a stack situation. The third example that we are facing is actually a very important computer science problem. How do you convert a number into a binary number? So assuming you already know, you know what I'm looking at. However, if you don't, that's totally fine. Let's take a look at this. Saying that we have a number of 26. So this is our daily life number 26. And we want to convert that into binary. You are required to write a program to convert that into binary number. The way for converting this number into a binary is the following things. First of all, you use 26 divided by 2. What you will get is 13 remaining 0. You need to store this 0 value. And then you take this 13 value to divide it by 2, get 6 remaining 1. And again, you need to store that value of 1. And then you take this 6 divided by 2, get 3 remaining 0. 3 divided by 2 equal to 1 remaining 1. And then you take this 1 to divide it by 2, get a 0 remaining 1. When you get a value of 0, that is when you can stop the operation. The thing is this. Based on all the remainders that we retrieve, we get this 0 first. So if we output all the remainder numbers that we have one by one, what we will get is 0, 1, 0, 1, 1, which is actually not the values that we need, because the value we need is actually a reverse order, which is 1, 1, 0, 1, 0. So we need to have a structure just like when we were playing the card or we are parking the cars. When we put the 0, when we get a 0, we store the 0 at the bottom, and then we have 1, 0, 1, and 1. And once we finish our operation, we will retrieve our values from the top to get a reverse order. So we will get 1, 1, 0, 1, and 0. This is the computer science example of how stack is implemented in our daily life. In fact, you already have stack concepts in your programming. You just don't know about it. In the end of this topic, I'm going to tell you what is happening, why I'm saying you already have this concept in your mind. So you can see for all the following problems, The basic operation for the playing poker game is push a card to or remove a card from the top of discarded pile. The basic operation for a car parking problem is you push a car onto the parking lot and remove the last car previously placed on the parking lot. The third example is that we notice the remainders are generated in a reverse order. Therefore, they must be stored in some structure so they can later be displayed in the useful left to right order. All of these is showing you the important concept, what we call the last in, first out data structure. And this is what we call a stack. There are two major operations. You can add things onto the stack, which is what we call push. So push is push an item to the stack is referred to as push the item onto the stack. When we try to remove something, that's what we call the pop. So removing an item from the stack, and it has to be the very top item. The last item that's been stored is going to be the first item you are going to remove, and that's what we call the popping the stack. So this is the stack operations. By mapping this concept into our ADT abstract data type, these are the following functions we need to implement. First of all, constructor, you need to create a space, no matter what kind of implementations. In fact, we will talk about 3 different kinds of implementations here, starting with the array implementation. So for array, you need to construct an empty stack. For linked list implementation, you need to have a pointer equal to null. Finally, we will look into a vector. For a vector implementation, we will create a space for the vector, and that is what we call a constructor. But at this stage, we don't care about the real implementation. We're just defining what are the important functions required for the stack implementation. Empty, again, is try to test whether or not your stack is empty. Push means that you want to push a value at the top of the stack. Top indicating that you want to retrieve the top item so that before you remove it, you will be able to output it or do some calculation about the value on the top of the stack. Pop indicating you want to remove that value from the stack. And finally, display is that you want to show all the things, usually from top to the bottom fashion. So these are the major functions required for us to do the implementation. And like I said, there are 3 implementations we want to discuss. The very first one is the array implementation. For array implementation, this is actually something very interesting to play with your mind. Regularly, we would think array looks like this. This is an array with capacity size of 7. So we have index from 0 to 6. And I believe everybody think array in this way. This is going to be the horizontal view of the array. So that now you may wonder, because the stack in our mind is going to be in a vertical picture. So actually, if we want to convert this horizontal array in our mind into a vertical way, there are 2 choices. One is that we turn this whole array in a clockwise, so that the 0 of the index will be on the top. Of course, there's another choice of turn this array into counterclockwise way, so the 0 will be at the bottom. Both of them have some advantages. However, one is better than the other one. Want to guess which one is a better one? The answer is that the second choice, which makes 0 at the bottom, is a better one. Why is that? We will need to see the algorithm analysis in this implementation. Saying that we choose the first choice, which makes 0 at the top, the advantage of this one is that whenever we want to push an item or pop an item, we know that the top is always at the index of 0. So this is always the target that we want to do. The only problem is that when we try to do the push, take a look at this example. If we push one more item, everything needs to shift 1 space down. so that there is going to have a linear operation of shifting items. And we know this is not going to be a light cost. If we're going to push one more item, we need to shift everything down. Even if we do a pop, we need to shift everything up one space. Therefore, this is not the best choice. Take a look at this one. When we try to put 0 at the bottom, everything is much easier. Because if we have items over here, we will be able to add items into it. So saying that originally we already have 6 items over here. When we try to push one more item, 95, we simply put 95 on top of what we already have. If we push another value of 80, we simply push a value of 80. If we want to pop it, we just remove one items out. The only cost, and this is minimum cost, the only cost of this implementation is that you need to create a variable to keep track of where is your top. Because it's no longer your top is at the index of 0. Now index 0 is meaning at the bottom, the very bottom items that you have. So that is the cost, which is one integer variable. That's it. So to design this, we're including an array to hold the stack elements and an integer to indicate where is the top of the stack. One more detail is that for constructor, when we create an empty array, my top will need to initiate it not equal to 0, because if that's equal to 0, indicating you have an item at the index of 0. So you may already guess, initiated the top value will equal to a -1. So that is indicating the whole stack is empty. Let's take a look at this one. To do a constructor, you need to create an array space. Define your data type, provide the name of the array, and then you of course need to define your capacity. So when you put your capacity over here indicating how many spaces that you will create, my top will need to equal to -1, indicating that the whole thing is empty. So for the empty function, if my top is equal to -1, then it is empty. Otherwise, it is not empty. So we have finished 2 operations. For push operation, this is actually very simple. If an array is not full, as long as it's not full means there's space. And how do we check the full situation? If my top is not equal to capacity -1, which is my top is less than capacity -1. When that's the case, when there are still space available, we simply increment my top by 1 and then store whatever value. So the push function will take 1 parameter indicating what is the item you want to push in, and so that you store the value x in the array. If it is full situation, then you just say it's out of the space. So you can see that in the beginning, if my top is equal to -1 and it's empty, and now we see a situation say push 10. When that's happening, then what we will need to do is that we will increment, since my top is not less than capacity -1, then we can increment my top by 1, so the top will become 0, and then we can put 10 into whatever space that stores over there. So that is about the push operation. For the top operation, indicating that you want simply get the value where the top located, because this is array implementation. As long as the stack is not empty, you just show array of that index, the top index, and that is your top function that you will retrieve whatever the value it is at the top of the stack. For the pop operation, it's actually even simpler. If stack is not empty, as long as it's not empty, you reduce my top by 1. And that's it. Okay? Again, when you do that, the top will go to the lower, one space lower, and even though there's still value stays in that original location, it will never be retrieved. If we push one more item after the pop, that value will be overwrite. If we want to do the top function, we will output the index that's already -1.